Hello, welcome to Chapter 11. Today we are going to be learning about area. Now we're going to be learning about basic areas on stuff that you would have been presented with in middle school, but we're just going to put it all together. All right, we're going to start off with three definitions. The first thing is the area. The, the area is the measure of space enclosed in a figure. Now this is much different than what we have for perimeter. So if I have some object, say this object, perimeter is the distance along this blue line. So that would be, perimeter would be a distance. Now area means how much space is enclosed in here. An area, what it does is it takes it and defines things by how many squares are in it. So if I divided a particular area into squares, how many squares of a certain size will be in that shape? Now, if I wanted to find the base of a rectangle or parallelogram, it's any side of that rectangle. It's kind of a dumb definition. It's any side of a rectangle or parallelogram. So it's not the best. It's maybe more concise than it needs to be. But I could pick any side of a parallelogram, and I could call this side the base. I could call this side the base. Any side I want, I can call the base. A lot of times people typically pick the bottom side, but you can pick this side over here, and that can be a base. Now, if that's the base, the height would always have to be perpendicular. So, or the height or the altitude, I should say. The altitude of either of those quadrilaterals is a segment perpendicular to the base with one endpoint on the base and the other endpoint on the opposite side. So here are some examples. Now, if I called this the base in this rectangle, then the height could be any perpendicular segment. It could be this right side or this left side, or it could be in the middle. If I did a parallelogram and I called this the base, again, we could pick any side or any distance, and this will be the height, or it could even be outside of the object, and that would be the altitude or the height. The height is just the distance of the altitude. Now if I picked this as the base, this is where it gets a little complicated. It's hard for people to visualize this. 90 degrees from this side would be about right here. Now, a lot of people think that looks kind of wonky, but if I actually went in and drew a square, and I put this in the corner, that'll tell me how accurate if it lines up. And that lines up pretty well with both sides. So that means that that does meet it at 90 degrees. So if this is the base, this is the height, which is going to be perpendicular to the base. Now the height of a rectangle is just the length of the altitude. So height and altitude are a lot of times used interchangeably. Now if I want to find the area of this figure, like I said before, we generally talk about it in terms of squares. So we just count up how many squares are in this object, and that's going to be the area. So 17, 18, 19, 20, 21. So I would say this is 21 square units. I don't know how big these are. Maybe it's a centimeter. If I was projected, it would be bigger than that. But we can just say 21 square units. Now if I want to find the perimeter, is it the same figure? Yep, same figure. So if I want to find the perimeter of this figure, now I'm just going around the outside. So that's going to be a distance rather than how many squares. So there's 1, 2, 3, 4, 5, 6 along that side. There's 5 along here, 3 up, 3 over, 3 up, and 2. So 6, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So my perimeter is 21 units. Now, since we're talking about straight distances, this is just a one-dimensional distance of units, not units squared. So if I want to approximate the area of this figure, we can count up the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now to figure out these, it's kind of hard to see exactly what they are. So what I would do is I would look at this chunk here. We know that this would be 6 if it's full, but I just cut that in half. So we know all of these has to add up to 3 together. So there's 9 individual ones plus 3 over here, so that's a total of 12 square units. Now the area of a rectangle is given by area equals the base times the height. So if I wanted to find the area of this, I just multiply that together, and then we can count up how many square centimeters would fit in here. So really, there's going to be 40 little centimeter squares in this entire object. Now if the area of this rectangle was 80 square inches, if I wanted to find this length here, that length, we would do area equals base times height. Maybe instead of, I should say base. Now area is 80. We know the height is 5. So if I divide by 5 on both sides, that would be 1, 6. So 16 inches would be the length of that rectangle. Now how could we find the area of this rectangle below, or parallelogram? Well, if I would cut this off and put it over here, notice how that would just create a rectangle, where this would be 7 and the height would be 4. So if I return it to its original place, finding the area of a parallelogram is the same as finding the area of a rectangle. Just 4 times 7, which is 28 centimeters squared. So we just take area of a parallelogram is given by the formula base times height. Now, here are 2 examples. Now this first example is the one that throws everybody off, because everybody likes to think that the base is on the bottom. But really what we need to keep in mind is the base is always perpendicular to the height that we have. So in this situation, I would do 9 times 12, and that would be my area. So 9 times 12 would be 108, and the units will be feet squared. In this situation, the height is 4, and that's perpendicular with 17. So 17 times 4 is going to be our answer. 17 times 4 is 68 centimeters squared. All right, so now let's find the area of this. Hopefully you can do this on your own. We have our base, which is 11, our height, which is 8. If I multiply those, I get 88 centimeters squared. In this case, our height is 12, so that means our base has to be perpendicular to that. So that's going to be 8. So it's going to be 8 times 12, which is 96 centimeters squared. So now this gets a little tricky. Now if I am just given this parallelogram and I want to find this height, what can I do? Well, it's the same parallelogram as the previous problem. I just added another line. We know the area of this shape is 96 centimeters squared. Now we also know base times height is going to be 96. So 15 times height will equal 96. So I just have to divide 15 on both sides, and my height is whatever 96 divided by 15 is. I just have to lunge for my wonderful calculator, and I have 96 divided by 15, and our correct answer is 6.4. So our height is 6.4 centimeters. Now we have another, this is a rectangle, and it says if the perimeter of that rectangle is 46, let's find the area. Well, if that side's 15, this side's 15, so this adds up to 30. So if I subtract 30 from that, these two sides have to equal 16. So if we cut them in half, both of them will be 8. So now to find the area of that rectangle, I just take 15 times 8, and I get 120 square centimeters. Now the area of a triangle, we've been doing this for a lot of the year. We can take the base times the height and divide it by 2, or some people just like to say 1/2 base times height. They're really the same thing. So in this situation, again, remember the height is perpendicular to the base. We take 15 times 4 and divide it by 2. So that's going to be 60 divided by 2, or 30. So this area is going to be 30 centimeters squared. Now the altitude of a triangle is 4 inches and the base is 6 inches. Label these and find the area of the triangle. Now the altitude of this triangle is 4 inches. So now it doesn't really tell us where that's at. We could say that this is 6 and the altitude could be like this, being 4, or we could have this being 6 and the altitude here being 4, or this one makes the least sense with this, but we could have the altitude here being 4 and that being 6. But that looks a lot bigger than that side. So I think probably the best one might be maybe this one, where that's 4 and this is 6. Now if I want to find the area, I take 6 times 4, which is 24, divided by 2, so 12 square inches is that area. Now if I want to find the area of this triangle, my height would be 5, that's perpendicular with 8, so my area would be 5 times 8 divided by 2, or that would be 20 centimeters squared. Now similarly, with our parallelograms, if I want to find this height, I can find it using what we got before, being 20 centimeters squared being the area. If my area is 20 centimeters squared, and I know this base is 7, 7 times h divided by 2 would be 20. 7 divided by 2 is 3.5. If I divide both sides by 3.5, 20 divided by 3.5 is 5.7. So my height in this situation is 5.7. The decimal keeps going a little bit, 5.714, but that's good enough for right now. Now try this one on your own first, and then restart the video and see how far you got. Now in this one we say that the area of the triangle is 70 centimeters squared. Let's try to find all of the other missing pieces. Now if we know that this base is 20, we know 20 times h divided by 2 is going to be the area, which is 70. Or 10 times h is equal to 70. If I divide both sides by 10, my height will be 7. Now if I want to find the value for x, that's a base. This height will be 10. So x times 10 divided by 2 will also be 70. So 10 divided by 2 is 5. 5 times x is 70. Divide by 5, and that would be 14. So this x here will be 14 centimeters. Now if this is y, the height for y would be perpendicular to y, which would be 12. So 12 times y divided by 2 would be 70. So 12 times y divided by 2 would give us 6y. So now we have to divide 70 by 6, and we have 11.6 repeating. So y equals 11.6 repeating. So those are those three values. All right, now we're going to look at trapezoids. The trapezoid, altitude of a trapezoid is a segment that's perpendicular to both bases. The height of a trapezoid is the length of an altitude. So those two words are synonymous. So here, if I want to find this, what I can do is try to find the middle of B1 and B2, which would be the average of those. So 1/2 base 1 plus base 2. And then if I took that, it would just be a rectangle, so we'd multiply it by our height. So that's the area of a trapezoid. Area equals 1/2 base 1 plus base 2 times height. Now if I wanted to find the area of this one, what I would do is I'd take 1/2, I'd add my two bases together, 6 plus 10 is 16, and then multiply it by the height, which is 5. Half of 16 is 8. 8 times 5 is 40, so this would be 40 square feet for the area of my trapezoid. Now if I wanted to find this, I add my two bases together, so it's 1/2. Base 1 plus base 2 would be 20, times my height, which is 7. Half of 20 is 10. 10 times 7 is 70, so 70 square feet. Now in this case, this gives us the area is 20. So if area equals 1/2 base 1 plus base 2 times height, we know the area is 20. If we add these together, we get 11, and then we have to multiply it by the height. Well, half of 11 is 5.5. Now we just have to divide 20 by 5.5, and we find out that the area is 3.63 repeating, for the 6th and the 3 repeat. So that's the height of that trapezoid. Now to find the area of this kite, we'll use the diagonals. And in this case, it's going to be 1/2 diagonal 1 times diagonal 2. So that's the area of our kite. 1/2 diagonal 1 times diagonal 2. So our diagonal 1 is the distance all the way across here. So that's 6 plus 6, which is 12. Our diagonal 2 is this whole distance, which is 3 plus 11, or 14. So my area is 1/2 12 times 14. So half of 12 is 6. 6 times 14 is 84. So my area of my kite is 84 centimeters squared. Now here I have my area of my kite being 30. So area equals 1/2 d1 times d2. We know this is 30. Our first diagonal would be 11. So half of 11 is 5.5. So I just take 30 divided by 5.5, and our second diagonal is 5.45 repeating. All right, hopefully this helps you remember basic areas. Good luck with homework.